Hello friends, I am Naren, your host and your friend. Today I am back with another DevOps playlist called Docker. In this playlist we are going to learn about Docker, all the concept about the Docker. And to start this series I am recording the introduction part for the first video of the Docker. So let's understand what is the Docker and why we need to use the Docker. So I here in this video I'm going to give you the overview of the Docker. Docker is an open source project that create and manage containers. Docker is written in Go language by Docker company. Previously it's known as DotCloud. Now we need to understand Docker is a platform as a service. That means it's a tool for PaaS, platform as a service product. And Docker use OS level virtualization to deliver software in container package. OS level virtualization is a virtualization technology that allow multiple isolated user space to run on a single host operating system. Docker. The idea of Docker is to develop application, ship them and ship them into container and deploy them anywhere. So Docker is very simple. You can build your application, run your application and ship these application to your production. The first release of Docker was March 2023. Since then Docker became very popular. Even today, Docker is widely used application for the containerization platform that allow you to package and run application and their dependency in a consistent environment. So previously you maybe if you are working as a team like without the Docker, that there is a problem that developers and QA often encounter. The problem is like developers saying that the application working fine in my environment, but QA saying the application is not working in the QA environment. Meanings like something is missing, the QA is something missing, but developer might forget to tell that missing part to the QA. So this kind of the common issues appear in the team. So Docker is because Docker is a containerized application, and we are Docker is working in such a way that it will be once you create a Docker image, it will make sure that that image run in any environment without any issue. So that kind of the problems is Docker solving. Now why to use Docker? Yeah, this is very good question. Why to use Docker? So consistent and isolated environment, meanings there is no more something is working in my environment but something is not working in some other environment. So once you build a Docker image, it will be consistent and isolated environment, so you can put it in any environment that can be okay. Now cost effectiveness with fast development. Since as I mentioned, Docker container in a Docker can run within a minute, meaning it will be also cost efficient and faster development. Cost efficient in the if you compare Docker with the Hyper-V virtualization system. So Hyper-V virtualization is installing a dedicated OS and then making it isolated, but Docker is sharing the your machine infrastructure and deploy a lightweight container, and it will be save a lot of cost. Flexibility, portability and scalability. Yeah, this is the great advantage that force you to use the Docker because it's flexible. You can use anywhere. Once you create a Docker image of your application, you can use in any environment, and it will be easily scaled. You can create multiple, many instance in simultaneous, many container in the simultaneously without a delay. Automation, of course, if you are working on the containerized, it is very easy to automate your application or automate your environment, whatever, all the automation. Like, if for example, if you are using a web-based application, so using the container, you can deploy your application easily, and you can run the UI automation on the newly deployed container. Similar way, all types of automation it can support. And Docker is little bit different than traditional virtualization system. So here you can see you have a machine here that has like an infrastructure, and you install the host OS. Doesn't really matter you are on Windows host or Ubuntu host, and then you can install the Docker engine. So Docker engine take the responsibility and shared your machine infrastructure like kernel and all this stuff. It will be shared and launch a container. This container is an isolated process in general, you can say. So it's act like a new operating system. It's act like a new, you deployed your application completely isolated environment. Now, let's understand the Docker architecture. Docker come with the Docker engine. Now, if at the very early version, Docker, there is also a good concept when you are using Docker, that Docker is help you to build to build microservices. Meanings, if you have microservices using a Docker, you can easily deploy microservices. Okay, so initially when Docker is first released, Docker was a monolithic application. Although Docker is claiming that it can be, building the build and deploy microservices very easily, but Docker itself was a monolithic application. So that in that application it has a Docker engine, that we call it a Docker engine. It include all three part, but in the modern release, in the latest release, Docker has uh, changed from monolithic application to micro service application. So in the Docker engine we have Docker client. This is one component, and we have a Docker REST API, second component, and then we have a Docker daemon that we also call Docker D. So you can understand is Docker engine act like client and server, where Docker D is become your act as a server, whereas client and REST API act as a client. Docker client and REST API act as the Docker client. Now inside the Docker daemon is calling a container D for managing the containers, right? And inside the containers call the runc for start. Actually, runc is for create and start the container and all this. Later we can see in the next slide, probably we will see what exactly containerd does and what exactly runc does. Okay, apart from this engine, docker architecture also manage containers, images, networks, and volumes. And from the client, like from the Docker CLI, you can also from Docker CLI, you can manage all these things. So this is the Docker architecture, where it has all are the separate component, by the way. Okay, so client and REST API treated as a client. Okay, when you are running any command, it's like a parse and send that command to the Docker daemon, and then Docker daemon uh, do some progress and response accordingly. Okay, so now let's understand Docker components. Previously we have seen Docker architecture. Now we are talking about the Docker component. Docker come with many components. So first one is the Docker engine. Remember, when I say Docker engine, that means it is already include the Docker client, REST API, and Docker daemon. Then we have a Docker registry. Docker registry is more like a repository where you can store your images. Docker registry, either private registry or public registry. For public, if you guys are familiar, then Docker Hub is called the public registry for Docker. By default, it's a public register that we are using, that called Docker Hub. And if you are using the AWS, then in the AWS you can also create a private registry called like a ECR, Elastic Container Registry. And then we have a Docker containers. This is another component. Then we have a Docker volumes, Docker images, Docker networks. Network is nothing but, it's communicating with the different network for different purpose. Apart from these common components, we also have supporting components. Docker Compose. This component is very helpful when you are building your uh, application or building your Docker image. You can use the Docker Compose. Now Docker Swarm is an optional component where you can it's act like a orchestration where you can manage multiple containers. If you have a big application, for example, like that application have many microservices, okay, you can understand in this way that if you have a more than 10 services, more than 5 services, you can use Docker Swarm to manage your containers. So this is the default come with the Docker, but recently most of the organization using the Kubernetes to manage their containers. And we have a Docker Hub. As we talk, the Docker Hub is nothing but a public Docker Hub, Docker registry that store all the Docker public image. And let's understand Docker execution flow. As a user, you run a Docker command, for example, Docker version. That command goes to the Docker CLI. Docker CLI send this command. Docker CLI take the command from the user, parse it and send it to the Docker daemon. Docker daemon process this command and responds back to the CLI, and then CLI will display the result of the user command, and in this way user can see exactly what happened. So this is the Docker execution flow. Now let's understand what exactly happened when you run a container. So the command that you see here, docker run /it ubuntu latest, it's a command that will help to create and run a container from Ubuntu image. And the image version, Ubuntu OS version, we use the latest. So you can go to the Docker Hub to see what is the OS version in the latest. If I am not wrong, that it will be have Ubuntu 24.04. Now when you hit this command, what happened inside the hood? The Docker CLI parse the command and send it via the Docker REST API to Docker daemon. Docker daemon we also call Docker D. Now Docker daemon check the image locally, because we are using the image here Ubuntu latest. So Docker daemon first task is to make sure whether this Ubuntu latest image exists locally. If it's not, then it connect to the Docker registry, which is technically Docker Hub, and download the Ubuntu latest image. Docker daemon, this is the first task of the Docker daemon. After the first task complete, Docker daemon delegate container creation to container D. Since we are run a container here, right, we are also creating and running the container D. So Docker daemon delegate container creation to container D. Container D handles the following: it image unpacking. Once we have, since we are using Ubuntu latest, so it will be do the unpacking of our image, and then it creates snapshot creation. It's basically file system layers, and preparing the container runtime specification, OCI specification. Okay, and then container D calls runc to actually create and start the container. Runc is responsible for the following: set up Linux namespace, since we are using Ubuntu on the Linux machine. So set up Linux namespace like PID, net command, mount, IPC, UTS, etc. Apply CG group, apply C group resource limit, and then mount the container's root file system from image layer. Execute the container's init process, in this case bin bash or bin ss if not specified. Okay, so this is how the Docker execution flow is working. So in this slide we have understand about the introduction of the Docker, where we can discuss all the component. And if you want to know more about, then you can visit my website. DevOps Learning Circle. So you can visit my website DevOps Learning Circle. Here we have few articles, and also we have a Jenkins pipeline, completely step by step all the instruction. And Docker, I recently start working on the Docker, so you can have a Docker overview where all the information I mentioned related to Docker architecture, how does this architecture is working, Docker container D, and how to get the container D version, and how to get the Docker, how to get the runc version, and Docker flow workflow. You can also, as we discussed the Docker workflow, how it Docker doing the workflow. And then you can also see the high level Docker architecture, like we have a Docker client where the client perform Docker run, Docker build, Docker pull. All the commands, all the CLI command talk to the Docker daemon, and Docker daemon perform the action. If it is Docker run, then for sure it will be, it will be go to fetch the image and then deploy the container. If it is building, and then you fetch the image and then deploy the container, and then fetching the image from the registry, as we discussed. So you can go through this article for more information. And for now, I would like to say thank you for watching this video, and stay tuned for my upcoming video. If you are new to my channel, I request you to like and subscribe my channel, and also press the bell icon to get the notification as soon as I publish a new video. So once again, thank you for watching this video. Have a great day. See you in the next video. Bye for now.